Hello, I'm Brian Walker from Copper Mountain Technologies. Last time I showed how to do a calibration where I did a 4-port calibration on the first 4 ports of our multi-port VNA, and I did a 2-port calibration on ports 7 and 8. So the multi-port is a 16-port 9 gigahertz box. This one's fully populated. It's also available in 6, 8, 10, 12, and 14 port versions. This one I'm going to show, as I said, a 4 and a 2. And I'm going to measure a splitter which operates well up to 6 gigahertz, and I'm going to measure a filter that is centered at about 4 gigahertz. And the first one is a 4-port measurement. I've terminated the other ports. It has many more. And the filter is a 2-port measurement. So I have 2 panes showing here on my display, which I have already set up. And I calibrated earlier. The left one goes from 300 kilohertz to 6 gigahertz, which is the 4-port measurement of the splitter. And the right-hand side is the 2-port measurement for the filter. So let's do a little bit more setup. I have 1 trace showing at this time, and it's S11, which is, that's this port on the splitter. All of the ports are the same. So I want to look at perhaps S21, or S11 and S21. So let's add a trace. And it already is S21. Let's allocate the traces so they're not on top of each other. Very easy to do. And it created a new trace, which I don't really want. I want S21 to be in that second bottom window, so I'll just pull it down there. And then S31, I will delete. So now I have S11 above and S21 below. The specification for this splitter is 20.6 dB insertion loss plus or minus 2 dB. So you can see that I'm measuring 19.5, which is within that range. So let's put limit lines on there just to make sure that we test this splitter. So we can show this. So I'll add a limit line, and let's make this maximum, and we have the full range, that's fine. We're going to go from 18.6, minus 18.6 dB, minus 18.6 dB again, so over that whole full range. Let's add another line, and this will be minimum, minus 22.6 and minus 22.6. We can show the lines, and we can now let's tell the table to go away, and let's make this 2 dB per division and set the reference to 20.6, minus 20.6. So now you can see it's centered, and you can see that the insertion loss from port 2 to port 1 of the splitter meets the specifications. S11 above that, I can add a marker to show what is happening there, and it looks like the return loss is about 16 dB in the middle, and it goes from like 28 up to minus 13. The specification for this splitter is 1.6 to 1, and I'm not going to translate that into the dBs at this time, but this is probably meeting that spec. So our splitter is easily tested here. The bottom panel, I could add S21, S31, or S31, S41, and S21, 31, 41, and so I could have 3 traces showing the various insertion losses. Now let's go to the other side and look at our filter, and that's on 7 and 8, so I have to change this. I want to look at S87. And you can see that it has drawn in the insertion loss. I'll push that up to the top. I'll add a marker, and then I'll do marker math and turn on the bandwidth search. And so now I've got all the statistics on this filter here. So that was very quickly done. Let's add a trace because I'm going to want to see the return loss as well. And that'll be S77. So you can see I'm measuring my filter and its return loss in the second pane. And it's going from 3.4 gigahertz to 4.6 gigahertz as I stated previously. So this is a completely separate measurement. So I have the splitter measurement on the left-hand side, left channel. On the right-hand side, I have the filter measurement. Notice that my channel is just designated channel 1. I could rename it, and it's probably good to do so. I'm going to call that splitter, and then the right-hand side, I'm going to call that filter. So now it's very clear what I'm measuring. So 2 measurements, very easily done. I've shown how I can drag a trace from one chart to another. I showed how I can use 2 channels at the same time to make different frequency measurements, and how I could group the ports into a separate 4 and 2 port measurement. There are other things that I could show, and in other videos I'll probably show how one can do time domain measurements with this multi-port VNA. Although we have shown in the past in other videos time domain measurements, it's really no different in a 16-port versus any of our 2 or 4-port VNAs. So this model comes with time domain gating, TRL calibration, all the analytical features that you've come to expect from Copper Mountain Technologies built into the VNA at no extra charge. So that's it for today. I think if you have more questions, please see our website, coppermountaintech.com, and I'll see you next time. Thank you.